Okay, students, we're back again. Last time we talked about different mineral properties, and this time we're going to be moving on to talking a little bit about how we extract these materials or mine them a little bit. So we'll talk about that a little bit as we go today. We finished off last time talking about different mineral classifications, about silicates being the most common, and then because we have so much silicon and oxygen in the world, and then these other elements here, which are different subgroups of minerals. There's lots of different types of them, like quartz is an example of a silicate, pyroxene is an example of a silicate, calcite here is an example of a carbonate, fluoride here is an example of a halide, gold is a native element, pyrite is a sulfate, and gypsum is a sulfide, hematite is another example of an oxide. These are just some examples of them, and I'll show you some as we go through this. And you'll learn more about them in your discussion as well. So, your discussion board. Okay, so now if we want an element that's in the middle, for example, in this phalite, has lots of iron in it, but it's a silicate. So it has these silicates have really strong bonds to them, and so they don't release the iron very much. So we have to really it's hard for us to extract the iron from this mineral. However, hematite, which is an oxide, is so much easier for us to extract that material because the silicon and the oxygen here, those are some strong bonds. But if you just have the oxygen by itself, we can take the iron out of that very easily. So if we're going to mine something, we're going to mine something that is actually not a silicate, it's a non-silicate, and try to mine these other materials. So if we go back to those materials here, if we want to mine something, we want to mine these materials, native elements, halides, because these are easier to actually extract materials. If you remember when we talked about mineral resources and mineral reserves, hey, I have that quartz here, my granite, and there is quartz in here. There might even be iron in here, even gold in here, but they're not high enough of quantities, or it's so hard to get it out that it's not worth our while to actually try to extract it. However, if I have pure crystals of quartz like this guy, this is so much better for us to mine because it's the pure nature of it. We don't have to separate it from anything else, right? So, so it's better to mine the native materials or some of these other things that we only have to separate two materials like iron and oxygen than all these stronger bonded materials of silica. So, I wanted to show you this because I wanted to kind of give you this last of all. You guys all have cell phones, right? Smartphones probably. And you'll know that inside that cell phone is so many different elements, and you have to be able to get the material for this cell phone. You had to get it from all over the world. You had to get indium for your screen, oxygen and tin, okay, for your screen. That's usually to make it stronger and collects electricity. So when you touch it, it can actually respond to you, right? Then you have silicon and aluminum, oxygen, and potassium. That's for your glass. Your silicon, your oxygen, your quartz. You put aluminum and potassium in to make it stronger so it doesn't break, right? Then you have things like this, which are rare earth elements. They're elements that are, if you remember in the periodic table, they're the ones at the very bottom of the periodic table. They're rarer in the earth. They're harder for us to obtain. Only certain places there are. One of the main places they are in China. So we use them all the time in our electronics today and some of our special electronics, but they're only used in found in certain countries, and so it makes us a little more dependent on those countries for those materials. Anyways, so rare earth elements we use for the bright colors and stuff like that we see in our phones. We use rare earth elements and other things like that as well in the battery to make the battery stronger. We use lithium and cobalt, carbon, the casing for magnesium, iron, nickel, the electronics within it. We use gold, silver, copper, and tantalum. I don't know that one. Anyways, the point comes is there's a lot of different elements that we use just for this thing. And to obtain that element, we have to separate the elements one by one from these different minerals, or to actually find them in these pure forms, which are a lot harder, and there's not as many of them. Okay, so I wanted to just do a quick review, just to kind of think about it. If the halide group is that last group in the periodic table, and then if the halide mineral group forms when atoms have ionic bonds between atoms with a dominant halide ion, based on your understanding of bonds and your discussion of the periodic table, which of the following minerals would be considered a halide? Now, if you remember that, the halides at the very end have 7 electrons. They want 8. So they want to actually to bond with something on the first part of the one, so you'd have the full electrons, right? So you have both to fill them. So you'd want something on the first of the periodic table and then something on the last, almost the second to the last row of the periodic table. That would be considered a halide. Okay, and so as you'll find out that these silicon and oxygen is not that. Most of these other ones are not that. Carbon is diamond is just by itself. And so the best example here is your sodium and your chloride, which chloride has 7 electrons and sodium has only 1. You do examples of this in your quizzes, by the way, but just to kind of give you an example of that. We didn't do bonds here, so I'm going to skip this one. I took this out of this one, and I forgot to take the bonds out of this quiz, so I'm going to skip that one for now. Okay, so ore deposits. These are something that we often mine quite a bit. Now, ore deposits are mineral deposits with high enough concentrations of a valuable element to allow it to be profitable. So usually what we call mineral reserves, if you remember, that's the economic aspect of one, they're often ores as well. Okay, so ore deposits usually deposit from crystallization processes and igneous rocks. They can do it from the erosion of surface materials that actually will concentrate them in certain places. You can have certain concentrations on the seafloor and so forth. But there are any places where you can actually have high amounts of that material. So places like that for Gold's Hill or Reed's Gold Mine up in North Carolina, up near Charlotte, they have all these rocks up there, and there used to be all volcanic activity there. And those volcanic materials, these igneous rocks, would come up in these cracks, forming these kind of cracks like this, and what would come up with it is gold. And so the gold would be in high concentrations in these cracks, and so that's what they would mine there up in Gold Hill and Reed's Gold Mine, is these quartz fractures, and therefore get the gold and extract the gold out of those fractures. Okay, it's the same example in other places around the world where they actually mine these fractures for gold and silver. Now, to actually get ores, we often have to go through a process of finding the ores, or exploring for them, or any kind of mineral resource, really. Exploring it, then extracting it, obtaining it somehow, and then concentrating it. Because often it's not in a very high concentration, so you have to concentrate it over time. There's ways to do that. So in this process, what we often do, we have to also go explore, mine the mining areas, explore, do geological maps, go out and look for these rocks. Then after we find the concentrations of the materials, we then often will have to extract it some way, either blast it or mine it in some aspect. Then we actually will what we call do beneficiation, which is basically break it down into smaller pieces so we can extract the material from it, okay? And then smelt, or by smelting, benefaction, or we call refining. And then after that, what we responsible mine would do would actually take that property and then put it back after it's done, after we extract the materials, and put it back to its natural habitat, and so we don't cause any environmental impacts then. Okay. So extraction can be done in a lot of different ways. We can do it what we call strip mining, which can be very dangerous, not very dangerous, sorry, very obstructive to the surface, or have lots of what we call overburden, things we take off the top, so mountaintop removal, and coal is an example of this, which is pretty detrimental to the mountains of the Appalachians. You can do sand mines or gravel pits, like we have a lot of those around here. This is the Bingham Copper Mine. This is one of the largest man-made holes in the world, where we get a lot of copper from in the United States. Or we can do underground mining, right, where we can go down underground and follow seams and things like that, or fractures, to obtain the material that way. Okay. All this can be very dangerous. Mining is one of the most dangerous businesses, by the way, in the nation. Excuse me. So, benefaction is really crushing the material or making it smaller to make it so that we can extract the material out of it. So often we would get the materials, put it on conveyor belts, put it in a big drum like this, break it down into smaller pieces, so then we can then extract it from there. And when we get in those smaller pieces, we can then actually separate the material by, in this case, this is an example of doing it by flotation, where we have chemical processes react with the materials, and the materials that you want will actually precipitate and go into a froth, go out, and then we can get the mineral from there, and what's left over is what we call tailings, or waste from the product. Now that waste can go into pause for. Sorry about that. I had to pause for a second. So that waste can actually be put into what we call tailings piles. And these tailings piles can be actually quite dangerous. And the reason is because lots of the stuff inside these rocks are broken down, and then you can start getting materials or heavy metals and sulfur and things like that come out of it, because now that you've ground it up, they actually are more, react more with water and other materials, and therefore you can start getting what we call acid mine drainage. So these can be somewhat dangerous when you mine. Now remember, if you don't get something, everything we have is from either the ground or grown, right? So if it's not grown, it's mined. And so we need these resources for our everyday lives, but lots of times it's at some cost. Okay, some environmental cost usually, and sometimes even economic costs or social costs. Okay, so for example, in the Appalachians, where they're mining for coal, they're taking whole portions of the mountain off the top of the mountainside, putting it into other valleys, contaminating the water in the region because of that tailing piles, and then contaminating local water supplies. It's pretty nasty stuff sometimes, and so it's sometimes necessary, but there's good ways of doing it and bad ways. Mountaintop removal, by the way, I'm very much against. There's other types of coal mining that's much safer and actually much more environmentally friendly than mountaintop removal. But anyways, side note. So when tailings piles, they often will try to put plastic liners on it to actually protect it and to try to reduce the environmental impact. Or they could actually take it, extract it by putting these big piles through it and put acids through it to actually leach out the material that you want and get it from the bottom, so to get that material over time. Now that means you have it using acids like with arsenic and cyanide and things like that, or sulfur and things like that, which is nasty stuff sometimes to get, and you don't want that to get in your water supply. So once again, it can be an environmental hazard. Now, another way of actually extracting things is by smelting. Lots of times different things have different melting points. And so if you actually start melting it, certain elements will float to the top or float to the bottom, depending upon its density, and you can actually extract it based off of its melting point. Okay, and so by doing that, they can separate the materials based off of their melting point by smelting. Now, after you're done with mining, you should really close the mine at some point. And there's tons of mines all over the United States that have not been closed properly. And they often become what we call Superfund sites, where there's high possibilities of contamination or things like that. Now, if that's the case, we have to clean that up slowly over time, and the EPA and the U.S. federal government actually has a program for that called Superfund. Hopefully the companies are doing that, but sometimes they go bankrupt. There's some loopholes in the law. They'll go bankrupt and not clean up after themselves. Now, if they do it the right way, they should do what we call reclamation, where they get that land and actually put it back to what it was before, where they get that waste rock and they replant it and stuff like that. So there's lots of times we can do remediation on top of that. So remediation, that's reclamation, sorry. And remediation is actually the process of fixing or removing that material slowly over time by actually treating the water or something like that to make it so it's no longer acidic. Okay, which is hard to do, and it's actually really expensive. Both of these are expensive, so that's why lots of mining companies don't like to do it. Okay, so but that's something, the way that we actually get a lot of these materials, or this mined material, is from these resources. Now I'm going to stop there for today, not for today, but for this lecture, and just to break that up. So that last section was about mining. The last section that we're going to be doing is talking about how we're now doing the difference between minerals and rocks, and how we use the rocks in our systems. Okay, so anyways.